Hey all, it's Mooch. Welcome to Your Mechs episode 21. Today we have the voltage drop testing of the Lost Vape Furyan squonking mech. This is a very, very long overdue video, and I apologize to Lost Vape for the extraordinary delay. And hopefully it performs well. Normal setup, we're going to have a fixed 30 amps pass through a solid aluminum slug, pass through the atomizer, through the mod, back out, and we're going to read the voltage drop over here. Right now it's 3.5 volts because that's what the power supply is set to. That'll deliver the 30 amps. And we'll read the voltage drop across the atomizer and through the mech. And then later, when I post the table, I'll subtract the effects of the voltage drop through the slug and through the atomizer, and you're left with just the power lost in the mech. So you can directly compare power losses for the different mechs from the table. And then we'll also do some arcing testing, where I'll fire 200 times. You won't have to watch that. And I'll check the contacts to see how badly the damage is, which can affect how often you might want to do maintenance and take down the high points or clean the contacts. And let's get this going. I'm going to use a 2700 slug, but this also takes a 21700. As a quick test, we'll just press the button and make sure this goes to 0 volts. And it does. And what I do is, to avoid any arcing damage from affecting any of the test results, as if arcing damage accumulates or affects the voltage drop, is press the button, then I use this to fire a 2-second pulse, and you'll see 30 amps appear here and 30 amps appear here. And then once the pulse stops, then I let go of the button. So there's no arcing in pressing the button or releasing the button. And we'll just read the voltage drop off here. For comparison, I just tested the Signature Tips SQ mod, and I got a 0.142 total voltage drop through everything. That's not the mech, that's what I read over here. 0.158 to start. After a couple hundred clicks, it dropped down at 0.142, I guess, as we wore down some high points. So that can give you a reference as to where this places. And I have to do my contortion because it's just not set up for me being a lefty. And you'll see as I press this button, this will go to 0 volts. And then with this hand, I will fire the pulse. That'll be off camera here, and then firing 0.190. Firing the pulse, 0.194. Firing 0.185. 0.187, and you'll always get a little variation because it really depends on how hard I'm pressing the button. That's a little bit harder than anyone would do when vaping. Just vaping, do that press. Now you can see it's 0.24, but I've tried to do a decently hard push for all the mechs just to try to make them equal. But just to give you an idea that you can affect the voltage drop, you can have it or double it just by how hard you press. If I go very, very hard, now you see I'm at like 0.148, a moderate push, 0.2, 0.21, and a light push, and we're 0.25. So it can be hard to get a very consistent, quote, correct reading. So I try to do this consistently as I can, and that seems to be about a 0.18, but we'll try a few more here. 0.175. 0.169, 0.18, 0.171. I'm going to do 0.175, and we'll check that after the arcing test to see if the 200 presses, if that takes down any high points or anything like that. So we got a 0.175 versus the 0.158, which is essentially no difference at all compared to the Signature Tips SQ mod. And use a Samsung 30T. And I'm going to fire this 200 times through a 0.1 ohm load with a Samsung 30T. And then we're going to strip this down and take a look at the contact points and see what kind of damage there is. And you won't have to watch this. I'll cut out most of the button presses. Let's get this set up. And 1, 2, 3, 6, 197, 198, 199, 200. Okay, and let's take a look. here you can see where the contact is made between the button and the 510 post. And so what I'm going to do is take a look at arcing, and I don't know if you can see it. You can see the arcing point, where the arcing is right here. It's just a single point, and then we'll also look at the contact, but I'll throw up, if I can get this to focus. I'll throw up a macro photograph so you can take a look. The loop has appeared, and let's take a look. Okay, it looks like there's actually two sets. Interesting. Definitely one set of contact points and damage in the middle of the test is done. There's beeping and ringing and dinging and goes on here every single hour. And taking a look at the button, yeah, the bottom of the button itself has all the arcing damage. It's not evenly across it. There's also a nub, a high point in the middle of the button, but that's not touching. It's just along the bottom of the button, a small arc. But I'll show pictures of that. And so I recommend, that was just 200 presses, and it's at a point where I would like to see this cleaned. Now, it's otherwise hard to get to these contacts. You can get to it just by doing a partial assembly, but let's try to put it together correctly. But otherwise, you take it out like this, and you could slip something in between here, but it's better to take it down and use a Scotch-Brite pad or something, because every time you get arcing damage, you get high points. And those high points make more high points, and the carbon residue and things like that just increase the resistance, which also makes for arcing. So arcing begets more arcing, so it's good to keep these cleaned. And also, because it's brass, things like these threads here that carry current from the top to the bottom, or bottom to the top of the mech, you need to clean these threads here. You need to clean the threads inside here. Not all the time, but well, as much as you practically want to. And certainly for the contact points here and here, clean those if you're looking for best performance. If not, you'll start to notice things heating up. Mech isn't hitting as hard as it was before. Well, that's a sign that you really need to start cleaning things. For the battery contacts, you can just use alcohol, because a constant contact between the bottom here and the top here, you don't have to worry about arcing or anything like that. Just alcohol wipe on these and you're fine. But it's really the threads and the contact points. And what we'll do now is I'm going to try to set up something for some thermal imaging and see if we can find out where any heating might be. Because we've got about 4 watts of heat, 3.7 watts of heat. And I want to know, does that happen at the contact point in the 510? Does it happen in here? Does it happen down at the bottom in these threads? So I'm kind of curious, but since we can't see the internals when the device is put together, I'm going to have to come up with some kind of way to set this up, and we'll see how that turns out. I forgot to do that retest of the voltage drop after 200 press to see if anything broke in, or to see if the arcing damage has caused any change in the voltage drop through the mech. I've got the normal setup, and press the button, get to 0 volts, and we read 0.178. What I read before was 0.175. That's about the average before. 0.166. That was a harder press, though. 0.187. 0.17. I'd accidentally pressed the wrong button. Okay. 0.175, 0.198. I am having to press harder. See if I can. 0.22, 0.20, but if I press a little harder, I can get the 0.178. So I would say for this one, whereas the SQ mods, the signature tips SQ mod, actually saw an improvement and essentially no arcing damage after 200 presses. This one, some obvious minor arcing damage. It's not, this isn't anything major. Most mechs have arcing damage of something or another, especially after 200 clicks with something like the 30T. But this one seems to affect the voltage drop a little bit, certainly not a lot, and you can just press a little harder on the button to compensate, but the voltage drop didn't get any better. And that's what the thing that I really wanted to test here, if anything got broken in or any high points got taken down. All right, let's see if I can do something for the thermal testing. Okay, I ended up having to skeletonize the Furyan, and you can see just the internal rods that are running here, the top plate that's here, the bottom plate that's down over here. You'll see all kinds of hot spots. This is where the metal is actually reflecting the lights and other hot sources around the room. It's not covered with flat black paint. The contact and other stuff is in here. This is the squonk bottle down here. This is the battery here. So over here is where we're going to be watching where the heating is. And I'm going to send 30 amps through here. Now this 30 amps is an extreme test. This isn't going to show you what the temperatures actually are. And you can see in the upper left-hand corner, 32C maximum, 21C minimum for what the camera sees. This is just to see where the heating is, not what the actual temperatures this device will reach, because this is continuous 30 amps. And let's start firing. Oh, okay, so that's pretty clear. Try to get some more of that strip. That is the brass strip and the 510 and the contact. Now they're up around 35 Celsius max. So they're heating up very quickly. So that's where our power loss is. Now this strip runs here, goes through a U shape here, and then goes over here to where the battery is. Now the battery acts as kind of a heat sink. The contact's pretty big, so the contact's not going to get hot. But you can see that U shape right here, because that's what acts as a spring to bounce the button back and forth. And the 510 connector in the middle right here gets hot. So the strip itself that runs from the contact across and then over, that's what's getting the hottest, and then the 510 is getting hot next. We'll try again. Now you can start to see the heat. It's actually heating up over here where the contact is. Now I'm not seeing really much of any heating down here. These bright little spots here on the left hand side where the threaded part is the negative end, that's just where I don't have flat black paint. Everywhere else has flat black paint and it's just not showing any heat. So there's no heating down the bottom in the threads as long as you keep it clean. All the power loss, about 4 watts, is up here at the top. And the performance of this mod was actually decent, better than the stainless steel tube mechs I tested, but not quite as good as the, why am I blanking out? Signature Tips SQ mod, which had about a 0.142 drop. This was a 0.175 drop. This one, you got some arcing damage on, which can be cleaned. It wasn't severe, and barely any arcing damage on the SQ mods. But they're very different mods, different looks, and neither I think is made for this kind of 30 amp use, which is about 105 watt vape. And this, you're losing about 3.7 watts through the SQ mods squonker. At 105 watts, that's a lot of power for a tiny box mod. For this one, you're losing, I haven't done the math yet, but probably 4 watts or so. Not too much of a difference between the SQ. And then you can build around it or just use it at a lower power level if you're using it like 60 watts, 50 watts, something with a higher resistance coil. Then, you're only losing 1.5, 2 watts or something like that on a 60 watt vape, and it's just not something you're going to notice. That's all for today. Thank you for watching.